Ah, yes. Let's solve an equation, shall we? We have negative 12 on the left. We have 2 plus 5v plus 2v on the right. If you have multiple things going on, try to combine like terms on each side first, like we were about to do here. That becomes 7v. And then the negative 12 and the 2 and the equal sign and the plus sign drops down. Now we have a two-step equation. So subtract 2 from both sides, subtract 2 from both sides, cross that out. Negative 12 minus 2 is negative 14. That equals 7v. And in order to get v all by itself, you do the inverse operation, which is divide 7 from both sides, divide 7 from both sides. Negative 14 divided by 7 is negative 2. Negative 2 equals v. Or I always like to put the variable on the left side. Not that it matters. It all depends on your teacher, but I like putting another variable on the left side. So there you have it. V equals negative 2. Solve the equation 3 equals x plus 3 minus 5x. Whenever you have several things going on one side, you want to combine like terms. So I have x and minus 5x, which will give us negative 4x because, 1 invisible 1 plus negative 5 is negative 4. X comes along for the ride. Speaking of coming along for the ride, that 3 equals drops down, that plus 3 drops down, and now we have a two-step equation. Always get rid of the number that's floating around first. So get rid of plus 3 by doing the inverse of it, which is minus 3, like so. Subtract 3 from both sides. 3 minus 3 is 0. So you might be looking at that and thinking, oh, I did something wrong. No, you didn't. So if you take negative 4 times x and you need to get rid of negative 4, do the inverse of negative 4, which is divide negative 4. Divide negative 4, and 0 divided by negative 4 is 0. So all is well. The answer is allowed to be 0. So flip those around because I always like putting my variables on the left side, although it's not necessary, but I just like to do it. And that's our answer. So x equals 0. 0 is a number. You're allowed to get that. So I hope this helps. All right, we have distributive property going on here. So let's distribute that negative 3 to this parentheses right here. Negative 3 times 1 is negative 3. Negative 3 times positive 6r is minus 18r, and that's going to equal 14 minus r. Now, I have variables on both sides of the equal sign. So it doesn't matter which one you do, we have to get rid of one of these r's by doing the inverse. So I always like moving my variables to the left, so I'm going to get rid of the variable on the right side by doing the inverse operation of minus r. Let's add r, let's add r. That crosses out. Negative 18 plus invisible 1r is going to be negative 17r, and then everything else just comes along for the ride. Negative 3 drops down, equals drops down, 14 drops down, and now it's just a two-step equation. Let's get rid of the constant, the number that's floating around first, by doing the inverse operation, which is going to be plus 3 to both sides. So let's add 3 to both sides, cross you out, drop down negative 17r, drop down positive 17, and in order to get r all by itself, we have to get rid of the negative 17 that's being multiplied to r. So let's do the inverse of that, which is divide both sides by negative 17, divide both sides by negative 17, and r is going to equal 17 divided by its negative self, negative 1. So there you have it, variables on both sides of the equal sign. Super fun. Ooh, distributive property and then some. Let's distribute that 6 to that parentheses right there. 6 times 6v is 36v. 6 times regular 6 is regular 36. And everything else drops down, comes along for the ride. So let's write that out. Now we have variables on both sides of the equal sign, but what we also have is the ability to combine like terms on one side of the equal sign. So let's take care of that. 36 minus 5 is 31. Drop down the 36v, that's v, that's positive, so make it 31 positive. 1 plus 6v on the right. Now we have these on both sides of the equal sign. I always like getting rid of the 1 on the right side because it puts my variable to the left side. So we're going to do the inverse operation of plus 6v, which is minus 6v, minus 6v, cross u out. 36v minus 6v is 30v. Drop down plus 31 equals 1. Now it's a two-step equation. Get rid of the constant that's floating around all by itself first. That's 31. So subtract 31 because it's the inverse of plus 31. So minus 31. Drop down the 30v. And 1 minus 31 is negative 30. Okay, v is still not all by itself. Divide both sides by 30 because 30 is being multiplied to v. Divide both sides by 30. And you get v equals negative 1. Yeah. Isn't that fun? Holy jeepers, look at this guy. First thing I would do is I would do distributed property, and it looks like we're doing it twice with two different sets of parentheses. So negative 2 times 2p is negative 4p. Negative 2 times positive 4 is negative 8. Now I have negative 3, not 3, but negative 3 times 2p. So you become negative 6p. And negative 3 times negative 2 is positive 6. Kind of a mess. The left side I'm going to leave untouched. I'll deal with that next. So drop down the 10p, the plus 9, the minus 11, never forget, and then the minus p. All right, so now that we have a bunch of stuff on the left side and a bunch of stuff on the right side, combine like terms on each side separately. So for example, I have 10p minus p, which is 9p. I was thinking ahead. I have 9 minus 11, which is negative 2. Drop down the equals. Let's combine the p's on the right side. I have negative 4p minus 6p, which is negative 10p. And then I have my constants, which is negative 8 and regular 6. Negative 8 plus 6 is negative 2. Now I have an equation with variables on both sides of the equal sign. I always like getting rid of the variable on the right side first, and I do that by doing the inverse of negative 10p, which is to add 10p to both sides, so plus 10p. That crosses out. 9p plus 10p is going to be 19p. Drop down the minus 2, drop down the equals, drop down the minus 2. Now I have a negative 2 and a negative 2, one on the left and one on the right. I wonder if something magical happens. I don't know. I guess we'll find out. I have negative 2 floating around. It's a constant. Always get rid of that one first by doing the inverse of negative 2, which is positive 2. So let's add 2 to both sides. And since I crossed this out, I guess it would make sense to cross that out too, which means the right side is going to be 0. So the left side is 19p. That's all that I have left over. In order to get rid of the 19, we have to divide both sides by 19 because it's the inverse of multiply. And when you divide 0 from 19, you get 0. I guess I should have said when you divide 19 from 0, you get 0, so p equals 0. The answer is 0, which is perfectly fine. You're allowed to have an answer of 0. So after all of that, we get nothing. So isn't that great? Hope this helps. Working together, Arjun and Maria can oil the lanes in a bowling alley in 4.24 hours. Had she done it alone, it would have taken Maria 8 hours. How long would it take Arjun to do it alone? This is a word-work problem, okay? Or a work-word problem. Listen, grammar doesn't matter. This is math. This is how you do it. You have person number 1. You have person number 2, and they work together to get a job done. Okay, so whatever time it takes them, you take the person number 1's time and do 1 over that. You take the person number 2's time and do 1 over that, and whatever their work is together, you do 1 over that. Now, chances are you're not going to know one of these things, so one of these will be an X and the other 2 will be a number. Now, let's see what we have. We have this guy, Arjun, And I don't know how long it's going to take him. That's the idea. So I'm going to set him as 1 over x. I have Maria. It takes Maria 8 hours all by herself, so 1 over 8. You're going to add these two and set it equal to them working together, and them working together is going to be 1 over 4.24. So not the prettiest number, but we'll deal with it the way we have to. Now on the left side, we have two fractions with different denominators. I can't combine them because the denominators are not the same. So the way you make the denominators are the same is you take the denominator of the one and multiply the other top and bottom by that denominator. So I'm going to multiply u by x over x. I'm going to take this denominator and multiply u by 8 over 8 because the denominator is 8. So 8 times 1 is 8. 8 times x is 8x. I'm going to add x times 1, which is x, 1x, and 8 times x, which is 8x again. Now that's good news because since we have the same denominator, I can add these fractions together. Now what about the right side? Nothing's changed. It's still 1 over 4.24. Yippee. Now that I can combine these, I have a denominator of just 8x. Remember, when you add fractions of the same denominator, you leave the denominator just like it is. Then you add these two guys up here. Now, I can't combine 8 plus x, so it stays 8 plus x. That's still going to equal 1 over 4.24. Now we have what's called a proportion. A fraction equals a fraction. When you multiply a proportion, you do cross multiplication and set things equal to each other. So I have 8x times 1. That becomes 8x. We'll write it up here. You set that equal to these two guys multiplied together. So 4.24 times 8 plus x. Now, why did I write that out first, the 4.24? Well, because I have distributive property. So what I need to do is I need to take this number 4.2r and distribute that to both things. Now 4.24 times 8 is 33.92. Did that right in my head. I didn't pause my video to see what it was. I'm going to add 4.24 times x, so 4.24x. The left side is still 8x. I'm going to subtract both sides. Since I have x's on both sides of the equal sign, I'm going to subtract both sides by 4.24x to get rid of the variable on the right. That crosses out. 8x minus 4.24x is 3.76x, I hope. Now I have 33.92 on the right side because that is crossed out. Now, in order to finish the problem, we need to divide both sides by 3.76 to get rid of the number in front of x, 3.76. And what I get is approximately, now this is a terrible number. It's actually, I did use a calculator for this, like 9.0212, blah, 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 blah. Now, it doesn't say where to round it to, but let's round it to 2 decimal places, so 9.02. So what does x equals 9.02 mean? That's how long it takes Arjun to do this alone. So how long would it take Arjun to do it alone? 9.02 hours. Give or take. Again, since this is a terrible number, we rounded it, and we got about that guy right there. So a little over 9 hours and like a minute, maybe a minute and a half. But that's how we do it. Not the easiest problem. I definitely am not a fan of these. They're kind of challenging, but hopefully the way I set this up helps. Scott left the airport and traveled towards the train station. 3 hours later, Castell left, traveling at 50 miles an hour in an effort to catch up to Scott. After traveling for 2 hours, Castell finally caught up. What was Scott's average speed? These are distance, rate, and time problems. So the main idea is the idea that distance equals rate times time. So what I have to do is I have to draw two pictures about two different people doing something that has to do with distance, rate, and time, and try to gather as much information as I can. So let's focus on Scott. Scott left one place, he traveled, and then eventually he stopped when this other guy caught up to him. What do we know about Scott? Well, he left the airport and traveled towards the train station. Who cares? 3 hours later, Castell left, traveling 50 miles per hour in an effort to catch up to Scott. After traveling for 2 hours, Castell finally caught up. So what do I know? Do I know his distance? No, I don't. Do I know his rate? No, I don't. Do I know Scott's time? Yes. Because he left, and after 3 hours, this other guy left, and after 2 hours, he caught up. So what I know about Scott is his time was t. But again, that's all I know. So let's take a look at the other guy, and let's take a look at his situation. Okay, he left 3 hours later. Okay, so they leave from the same exact spot. He's traveling at 50 miles an hour, so we have a rate for him, and his rate is 50 miles per hour. In an effort to catch up to Scott, after traveling for 2 hours, he caught up. So this is what we know. His time was 2 hours, his rate was 50, and his distance that he traveled was the same. So these guys have the same exact distance. So this is what we know. We have Scott, we have Castell. I hope I'm pronouncing that right. Their distances are the same. Their distances are the same, which means their rate times time is the same. So we have Scott's rate, we have Scott's time. So I'll put RT knowing that I'm going to erase this, and R and T knowing I'm going to erase that. So we have Scott's rate, which I don't know. We have Scott's time, which I do know. That's 5. So I'm going to replace Scott's T with 5. We have Castell's rate, that's 50. I'm going to replace Castell's rate with 50. And we have his time, which is 2, so I'm going to replace that with 2. So now in an effort to clean this up, I have R times 5, which is 5R, equals 50 times 20, which is 100. Divide both sides by 5, divide both sides by 5, cross you out, and R equals 20. Now, what does that mean? Well, the R that I have is the rate for Scott. Okay, so we're dealing with hours, we're dealing with miles, we're dealing with miles per hour. Scott's rate, or his average speed, was 20 miles per hour. So that's how we do these problems. You have D equals RT. You try to figure out the things that are equal to each other and try to draw pictures of what you have. There might be times where the rates are different. There might be times where the times are the same. It doesn't really matter. You're just trying to figure out what's equal and base some type of equation off of that. And this is what we came up with. Bronze, which costs $9.10 per kilogram, is made by combining copper, which costs $8.90 per kilogram, with tin, which costs $9.50 per kilogram. Find the number of kilograms of copper and tin required to make 15.3 kilograms of bronze. Now, this is a mixture word problem. Mixture word problems are difficult. So what I like to do is I like to make a table where I have my object, right? So I have 3 of them, 3 objects. I have bronze, I have copper, and I have tin. I have my amount, so whatever the amount is in kilograms, I have that. I have a value of them, so in this case, the value is cost. And then from that information, I create an equation. That equation is going to be the amount times the cost for each object. Now, let's make our rows of our 3 objects. Okay, not the prettiest table in the world, but I'm not here to win any awards. All right, so let's take a look at the total thing, the end result, which is bronze. So I'll put that right here, bronze. Okay, what do I know? I want to make 15.3 kilograms of it, and I know it costs $9.10. So in order for me to come up with an equation for this, I need to find out how much 15.3 kilograms of bronze costs at $3.10, $9.10, and I'm going to multiply those two numbers together. So the number that we get when we multiply that is $139.23. Okay? Fun. Now, what else do we have? So that's object number one. I have copper. Copper costs 8.9 kilograms per whatever, per kilogram. I just said that. Copper costs $8.90. Do we know how much we have of this? No. So I'll call you X. Okay, so the equation that we have there is going to be 8.9x, because I can just turn 8.90 into 8.9, multiply x to it, and there you have it. So that's our copper option. Copper, the name of the dog from The Fox and the Hound. Cute movie. Tin costs 9.5. Okay, so the cost for this is $9.50. That's tin. And do we know the amount? No. So this is where we have to be a little clever here. I don't know the amount of copper. I don't know the amount of tin. But what I do know is that the total amount is 15 plus 3. So going off to the side, if we knew we had 10 pounds of stuff and we knew we had 7 pounds of other stuff, wouldn't we find out what we have left over by doing 10 minus 7? We would. So if we know we have 15.7 kilograms of stuff and X pounds or X kilograms of other stuff, the other stuff is going to be 15.3 minus X. Okay? So something to remember, challenging for sure, but what that gives us is a distributed property problem of 15.3 minus X times 9.5. Now, when we set up an equation, I will change that around a little bit. Okay, but these are the two pieces of information that we have. Now, common sense would tell us that the copper plus the tin is going to equal the bronze. So what I'm going to do for the equation that I set up is I'm going to do 8.9x plus 15.3 minus x in parentheses times 9.5 equals 139.23. So I have 8.9x plus, and I am going to rearrange this to make it a nicer looking distributed property problem, 9.5 times 15.3 minus x equals 139.23. Step number one, distributed property. Okay, 9.5 times 15.3 is 145.35. 9.5 times negative x is minus 9.5x. Coming along for the ride, we have 8.9x and equals 139.23. Let's combine the two variables on the left side. 8.9x minus 9.5x is negative 0.6x. Now, you might be a little nervous by that negative, but we'll see what happens. We'll see what happens. Right here, I drop down the positive 145.35, okay, because that was positive. I may have forgotten a plus sign there. And that's going to equal 139.23. Let's subtract both sides by 145.35 from both sides. Cross u out. And we get negative 6.12. So drop down the negative 0.6x, and we now have a somewhat friendlier problem to deal with. Let's divide both sides by negative 0.6 divide both sides by negative 0.6. So if you were nervous about all those negatives, you'll be happy to know that the negative and the negative cancel each other out. And what you get is x equals 10.2. Now, what does that mean? The x that we had over here is the amount of copper that we have. So we have 10.2 kilograms of copper. They want us to find copper and tin. How do we find tin? Well, tin was 15.3 minus x. So let's go somewhere down here and do 15.3 minus the x that we got was 10.2. And 15.3 minus 10.2 is 5.1. So 10.2 kilograms of copper, 5.1 kilograms of tin. And that's what we need to answer this problem. So mixture problems are very, very, very challenging. But the best thing to do is to make a nice little table like we did. It takes time, but we got it right. And it was so much fun. All right, so we're going to solve a pretty basic absolute value equation. We have an absolute value of blah, blah, blah equals 9. Whenever you have an absolute value equation, what you need to do is get the absolute value all by itself, which it is. Once you have that, what you do is you write out the complete left side, negative 3r and negative 3r. Now we're splitting this up into two separate equations because the absolute value could equal its positive version or its negative version. On the right side, we're going to have the original right side, and on the other right side, we're going to have its opposite. Okay, so we split this up into two equations, negative 3r equals 9 and negative 3r equals negative 9. And you solve each equation separately. Divide both sides by negative 3, divide both sides by negative 3. R equals 9 divided by negative 3 is negative 3. Easy peasy. Do the same thing over here. Divide both sides by negative 3, divide both sides by negative 3. R equals negative over negative is a positive, so positive 3. Now, before we're done, mentally check your work. Negative 3 times negative 3 is positive 9. The absolute value of positive 9 is 9. Checkarooski. Negative 3 times positive 3 is negative 9, but the absolute value of negative 9 is positive 9. Checkarooski. So we have two answers. We have negative 3 and we have regular 3, and that's how you do a simple absolute value equation. Dunzo. All right, we got an absolute value equation. Now, whenever you see an absolute value equation, what you want to do is get the absolute value all by itself, and it already is. Once you have the absolute value all by itself, you split it up into two separate equations. For each equation, you're going to write out the absolute value side without the absolute value. So negative 4 plus 5x and negative 4 plus 5x. On one equation, you're going to keep the right side the way it originally was. And on the other equation, you're going to take the right side and take its opposite. Now we have two separate two-step equations that we need to solve for and do one at a time. So let's add 4. Let's add 4. Cross you out. 5x equals 20. Divide by 5. Divide by 5. X equals 4. So that's one of our guys, maybe. Now we do this guy too, add 4, add 4. 5x equals negative 12. Divide both sides by 5. Divide both sides by 5. And x is going to equal negative, 2.4. Now we take our answers and plug that into the original problem to make sure it works. So x is 4, 5 times 4 is 20, 20 minus 4 is 16, and the absolute value of 16 is 16, check. 5 times negative 24 is negative 12. Negative 12 plus negative 4 is negative 16, and the absolute value of negative 16 is 16, so both of these work. More often than not, these will both work, but you still have to make sure just in case that one time it doesn't. So I have two answers, 4 and negative 2.4, and we're done. Whenever you're solving an absolute value equation, what you need to do first is get the absolute value part all by itself. So if you're multiplying a 3 to it and adding an 8 to it, you get rid of them like you would for a normal two-step equation. So what I'm going to do first is subtract 8 from both sides, cross you out. So now I have 3 times the absolute value of negative 8x equals 72. Now I still have to get rid of that 3 that's lingering out in front. And the way we do that, since it's being multiplied, is we divide both sides. So now we have the absolute value of negative 8x equals 24. Okay, now that we have the absolute value all by itself, we split it up into two equations. Whenever you have absolute value of stuff equals two equations, or equals a number, you write out your left side for both left sides. So just get rid of the absolute value and rewrite negative 8x. Write out the original right side and the opposite of the right side. Now you solve each equation the way you normally would. Divide by negative 8. Divide by negative 8, x equals negative 4. And then divide by negative 8, divide by negative 8, x equals positive 4. You go back, you plug things in, make sure they both work. Trust me, they will both work. I mean, if I were to do 8 times negative 4, that would be positive 24. The absolute value of positive 24 is 24 times 3 is 72 plus 8 is 80. And if you were to plug in regular 4, the absolute value would make negative 24 positive, and the same exact thing will happen. So we have two correct answers, x equals negative 4 and x equals positive 4, and we're done. All right, when solving absolute value equations, the first thing you have to do is get the absolute value all by itself. I have 5 being multiplied to the absolute value, and I have minus 7. I got to get rid of both of them. So let's add 7 to both sides, like so. So now I have 5 times the absolute value of 9 minus 5n, close it, equals 45. Okay, since that 5 is being multiplied to my absolute value, let's get rid of it by dividing both sides by 5. Divide both sides by 5. And now we have the absolute value of 9 minus 5n equals 9. Now that the absolute value is all completely by itself, I can rewrite this as two separate equations. My two equations, the absolute value part is going to stay the same. You just get rid of the absolute value. So 9 minus 5n, 9 minus 5n. The right side on one of the equations is the original right side, and the right side on the other equation is going to be the opposite of the original right side. So minus 9 for that guy. Solve for n. So I'm going to subtract 9. I'm going to subtract 9, cross you out. Ooh, look at that, cross you out too. Negative 5n equals nothing. Divide both sides by a negative 5, divide both sides by a negative 5, and n equals a big fat 0. Now to do the other guy, we're going to go through the same process, but unfortunately the number is not going to be near as pretty. Subtract 9 from both sides, subtract 9 from both sides. Negative 5n equals negative 18. Divide both sides by a negative 5, divide both sides by a negative 5, and you're looking at n equals positive 3.6. So not only is n 0, but n is also going to equal 3.6. Now what you're supposed to do is take these answers, plug them in up here, do a little bit of math, make sure they work. They do, trust me, I promise. They will work. And yeah, that's our guy. So we're donezo funzo, baby. Let's solve and graph an inequality. Ooh, these are fun. The way you solve and graph inequalities is exactly the same way you solve and, well, not graph, a regular equality. So what I'm going to do first is I notice that I have 1 minus 1 on the left. Let's just combine those and get rid of it, please. It becomes 0. Now, what I have is 4x is greater than or equal to negative 8. Let's divide both sides by 4, divide both sides by 4, and now x is all alone is greater than or equal to negative 2. That is my solution. What this means is x can be any number equal to or larger than negative 2, like 5 and a billion. So how do I graph that on a number line? Well, I'll put -2 in the middle because why not? So I'll make you -1, 0, 1, 2, 3. I'll make you -3, -4, -5, -6, and -7. Now, we are supposed to again say that x is allowed to be any number including -2 and larger than that. So if we want to have including -2, we put a circle at -2 and fill it in because we are also equal to -2. If I want everything greater than that, I highlight the right side of it because that represents greater than on a number line. And now that purple arrow is saying my answers could be -1 or 0 or 0.5 or 2.5 or a billion, whatever. That's how you solve and graph an inequality, boys and girls. Solve and graph this inequality here. Ooh, distributed property. Let's do that first. Let's multiply -2 to everything. So you become -2n. -2 times -4 is +8. Drop down the 3, drop down the greater than, drop down the -1. Okay, before we do anything, let's combine the like terms on the left. 3 plus 8 is 11, so 11 minus 2n is greater than -1. So far, nothing different than solving a regular old equality. All right, still nothing different. Minus 11, cross you out, -2n is greater than -12. This is where it finally gets different. If when you solve an inequality at any point you multiply both sides or divide both sides by a negative, you have to flip the inequality sign like that. Okay, so dividing both sides by a negative has me go from greater than to less than, and -12 divided by -2 is +6. That's me solving. Now, the way I graph that is this is saying all of my n values have to be less than 6. Oh, you're not allowed to include 6, but it's got to be less than 6. So we'll put 6 here. So you're going to be 7, 8, 9, 10, 11. You'll be 5, 4, 3, 2, 1. And when we want to show that it's not equal to 6, we put a circle at 6 and don't fill it in. Filling it in means include the 6. Don't fill it in means don't include the 6, and we don't want to include the 6. We're going to highlight our arrow less than 6, so this is going to go below the 6. And what this means is for the original problem, I'm allowed to take any number less than 6, substitute it in, and it'll work. I can plug in 0, I can plug in 4, I can plug in -1 billion, and this will become a true statement. Any number that I plug in that's below 6 and not including 6 will be greater than -1. All right? Solving and graphing inequalities. Fun stuff. All right, let's solve and graph this inequality over here. We've got distributed property. Let's do that first. The negative of a parentheses just means you flip the signs inside the parentheses. -k is +k. -3 is +3. Drop down the dose. Drop down the 7. Drop down the less than. On the right side, I have 3 plus 2, so let's just do that. K plus 5. On the left side, we have 7, so 7 is less than k plus 5. Subtract 5, 2 is less than k. Now, some teachers might be okay with you circling that and calling it a day. This teacher is not. If 2 is less than k, the way you should write it out is 2 is less than k, so k is greater than 2. Flip everything, including the sign. Now, the reason why I do this is now it makes graphing a little bit more sense. This means our answer has got to be any number greater than 2. Not including 2, but any number greater than 2. So when I graph this on a number line, I put 2 wherever I want. So this will be 3, 4, 5, 6, 7, 1, 0, -1, -2, -3, right? To graph k is greater than 2, I put a circle at 2 and don't fill it in. If you fill it in, you are saying that we're including 2, but we don't want to include 2. If k is greater than 2, then I'm going to highlight everything to the right side of it like so. And this graph now says that if I take any number greater than 2, like 5, like 7, like 7.5, like a billion, and plug it into the original equation, 7 is going to be less than whatever number I choose. Okay, so there you have it. That's how you solve and graph an inequality. All right, let's solve and graph this inequality with distributed property. Let's distribute first. 5 times negative 6 is negative 30. 5 times 3m is positive 15m. And drop down the 26 plus m is greater than or equal to. Now we have variables on both sides of the equal sign. With inequalities, I prefer to have my variable on the left side, so I'm going to subtract both sides by 15m, just like that. That crosses out, and now we have 26. M minus 15m is minus 14m is greater than or equal to negative 30. Now I have myself a two-step inequality. Subtract 26, subtract 26, cross you out. Negative 14m is going to be greater than or equal to negative 56, like so. Now I'm about to divide both sides by negative 14. Whenever you take an inequality and multiply or divide by a negative, you must flip the sign. So greater than or equal to becomes less than or equal to regular old 4. Now put your 4 wherever and then fill in your other numbers like so. While I'm doing this, what the answer means is that my numbers that I'm allowed to plug into the original equation are any number that is 4 or smaller than 4. So I circle and fill in 4 because I'm including 4, and then I'm going to go to the left of it because anything less than is all good too. So I could take numbers like negative 1, negative 0, negative 100, and plug that into both m's of the original equation, and that will still make a true statement. Okay, so a lot of stuff to do there, but not so bad. Fun. Look at this gross looking inequality. Well, I see two distributed properties, so let me take care of that first. Negative x is negative x. Negative positive 2 is negative 2. I'll drop down the 5x right here while I'm at it, is greater than. Negative 5 times 1 is negative 5. Negative 5 times x is negative 5x, and then drop down the positive 3. Now that we've taken care of distributed property, let's combine on both sides separately. So 5x minus x is 4x. That gives me 4x minus 2 is greater than. Negative 5 and 3 combine, so those combine to make negative 2 and then minus 5x. Now I have variables on both sides of the inequality. I prefer to have my variable on the left. So I'm going to add 5x to both sides, add 5x to both sides. That crosses out. 9x minus 2 is greater than negative 2. Now, this is good news. Why? Well, since I have negative 2 on the left and negative 2 on the right, by adding 2 to both sides, they both cross out, leaving me with 0, and it's about to make my life a whole lot easier. Because the last step is to divide both sides by 9. And when you divide both sides by 9, let me write it over here, 0 divided by 9 is 0. So my answers are going to be any number greater than 0, but not including. So let's draw our 0 and our other numbers out like so. Let's forget the negatives. And when I graph my circle at 0, that's an ugly negative 5. I'm going to make sure that I don't fill in the 0. So here's my 0. Don't fill it in. I want everything greater than that. So let's shade heavily to the right. And what this means is I'm allowed to take any positive number, like 1, like 50, like 3.5, and plug it into all of the x's in the original equation, and it'll end up being a true statement. Okay? So pretty crazy inequality, but pretty fun too, right? Right. We have ourselves a compound inequality. Whenever you see a compound inequality, you solve each inequality on its own. So let me solve u over here. N plus 1 is less than or equal to negative 3. Simple one-stepper, minus 1, minus 1. N is less than or equal to negative 4. Bada bing. Then let's solve that one individually. Negative 4n is less than negative 8. We have to divide by a negative. And whenever you divide or multiply a negative from an inequality, you have to flip the signs. So our final word answer for this guy is n is less than or equal to -4 or n is greater than 2. Now, whenever you have an or statement that's an inequality, you graph both equations on the same number line. So I have to deal with -4 and 2, so I'll put -4 over here. I should be able to reach it just fine. So -3, -2, -1, 0, 1, 2, 3, 4. There's -5, -6. The graph of n is less than or equal to -4 is going to look like this blue line. Fill in the circle for -4 because we're including -4, and we're going to shade everything below that. Since you're already green, I'll keep it green. N is greater than 2 means you fill in the circle at 2, don't fill that in, and you shade to the right. Now, these shadings means that if I pick any of these numbers, that will satisfy the answer up here. And since this is or, like, this green one came from this guy. If I were to pick 5, 5 would work for you, but wouldn't work for you. But that doesn't matter because I only want one or the other. In fact, there's no number that's going to work for both, but I don't need it to work for both. I need to pick a number that just works for one or the other, and that's how you do an or inequality graph. Super fun. We have ourselves a compound inequality, and this is one of those in-between kinds. So whenever you have an in-between kind, you look directly in the middle and you solve it just like you would solve a regular old equation or inequality. You get x all by itself. How do you get x all by itself? Subtract 6 from all three sides. I said that correctly. And when you do that, you have 0 is less than or equal to x, which is less than or equal to 5. Now that means x is in between 0 and 5, and you're also allowed to include 0 and 5. So we go down to our number line. We'll put 0 here. 1, 2, 3, 4, 5, 6, 7, 8, -1, -2. We include 0, so fill that in. We include 5, so fill that in. The numbers we care about have to be in between that, so fill in the in-between. So there you have it. That's an in-between problem. Just, solve all three sides like we kind of did. Interesting. Solve and graph that abomination and that other abomination. Well, this is a compound inequality that is also an and, so one thing at a time. We'll make you blue. 8p minus 13 is less than or equal to -2 plus 7p. Let's get rid of the variables first. I like to always make sure that my variable's on the left side, so let's subtract 7p. Let's subtract 7p. That crosses out. 8p minus 7p is p. P minus 13 is less than or equal to -2. Okay, one stepper now. Add 13, and p is less than or equal to 11. Okay, donezo. This guy, I'll make you red, is going to be 20 plus 4p is less than 2p plus 14. Approach it the same way. I like my variable on the left side. Subtract 2p, and that gives me 20 plus 2p is less than 14. Subtract 20, that crosses out. 2p is less than -6. Divide by 2, and I'll write it over here. P is less than -3. Now, these are both less thans, okay? And whenever you have an and statement, you need to make sure that whatever your final answer is covers both things. So for example, if I were to make like a rough draft of this, right? Here's 11, here's -3. All right, 11, the blue guy would look like this. Fill in the 11, go to the left. The red guy would look like this. Fill in the -3. Actually, don't fill it in, but move to the left. Now, what matters here is I care about where both lines intersect each other because this is an and statement. So that happens at -3, but not including -3. So from here on to the left, both of these lines cover each other. But since -3 is not included here, I'm not going to include -3 in my final answer. So my answer is going to be -3, not filled in, moving to the left. Like that. All right? So that's what you're looking for with these and statements. With the and statements, you care about where both of your lines intersect each other. And in this case, they were both heading in the same direction, which is unique, but not impossible. And as long as you put your heart to it, nothing's impossible, right? Am I right, kids? Like and subscribe. What up, what up? We have ourselves a compound inequality that we have to both solve and graph. So whenever you're given a compound inequality, which means here's one, here's another, and it's separated by the word or this time, you solve each one individually. So let's solve u on the left. I always like having my variable on the left side, so we'll subtract 8x from both sides like so. Regular x minus 8x is -7x. Drop down to plus 18, drop down to greater than or equal to, drop down to 4. Now it's a two-step inequality. Subtract 18, cross you out, drop down to -7x is still greater than or equal to -14. Now, the next step is to divide both sides by -7. Whenever you multiply or divide an inequality by a negative, you must flip the sign like that. And so this guy started out like this and ended up like x is less than or equal to 2. Now the other guy is going to be really strange, and you might see why off the top. All right, 15x on the left, 15x on the right. Subtract 15x, subtract 15x, you disappear, and you're left with -15 is less than or equal to 5. Now, whenever your variables all disappear, which they did, and you're left with nothing but numbers, you are asking yourself, is this a true statement or not a true statement? Is -15 less than or equal to 5? And the answer is yes. And when that's the case, the answer is infinite solutions, or all real solutions, depending on what your teacher is, or infinitely many solutions. The wording doesn't really matter. So my answer in this case, verbally, is x could be less than or equal to 2, or everything. So if you're wondering, all right, well, I remember that if it's an or statement, you're allowed to have both graphs on the thing. That's true. But if the answer is infinite solutions, you're still going to end up with the entire number line as your answer. It doesn't matter that part 1 says it can be less than or equal to 2. The fact that part 2 says it's also, or it could be also, everything means that your number line is just going to cover everything. So that is ultimately our answer. The ultimate answer is that it's infinite solutions. And so when I graph the entire number line. I'm not even going to label it. You can't make me. We have ourselves an absolute value inequality. Now, with absolute value inequalities, the first thing that you need to do is get the absolute value all by itself on the left, and it is. Once it's on the left, what you do is you split it up into 2 equations. You keep the left exactly the way it is for both of them. For one of the equations, you keep the right and the symbol exactly the same. So still less than or equal to, and still 18. For the other inequality, you flip the sign and make that its opposite, like so. Now, the other important thing here is a word that goes in between these. If when you split them up, you have a less than or equal to, it is an and statement. Okay, always remember the phrase greater, less than, and this is a less than statement. So now we solve each guy individually. Okay, divide 6, cross you out, n is less than or equal to 3. And divide 6, cross u out, n is greater than or equal to -3. Now, when you graph and statements, make yourself a little rough draft over here, draw yourself a perfect line like I just did, and figure out, all right, well, I need to make sure that since this is and, my final answer is where both of these lines intersect each other. So if you were 3 and you were -3, graphing this guy is going to look like this. Put a 0 or a dot rather on 3, fill it in. Put a dot on -3 and fill that in. Where these guys overlap completely is between -3 and +3 and everything in between. So that's going to be what my final graph looks like. So we'll put -3 here, -2, -1, 0, 1, 2, 3, 4, 5, -4, -5. We'll fill in a circle at -3. We'll fill in a circle at regular 3. And we'll fill in everything in between. And that, ladies and gentlemen, is a very basic absolute value inequality. Fun! What up, what up? We have ourselves an absolute value inequality. And in order to solve and graph an absolute value inequality, step number 1 is to make sure the absolute value is all by itself on the left. Happy news, it is. Once it is, you split this up into 2 separate inequalities. For each inequality, you just write out whatever's inside the absolute value just like it is. Don't make it positive because you see absolute values, you're not going to want to do that. One of your inequalities is going to have the exact same symbol and the exact same right side. The other inequality has you flipping the symbol and making the right side its opposite, so 11 becomes -11. All right. Now what you're going to want to do after that is figure out, I need a word in between. Well, I remember a phrase called great or less than. This is a greater symbol, which means the word in the middle is or. Great or less than. So now I have 2 separate inequalities that I have to solve for with an or in the middle. So let's solve each one individually. +3, +3, cross you out. -8a is greater than 14. Gross, divide by -8, divide by -8. Gentle reminder, when you divide both sides by a negative, you flip the sign. 14 divided by -8 is -7/4. So -1.75. We'll deal with that when we have to. And then I have an or statement. Treat this guy the same way. Add 3. Add 3. Fortunately, this one's friendlier. -8a is less than -8. When you divide both sides by a negative, you flip the sign. And what I'll do is I'll rewrite the whole thing in the middle. Once we're done, we can rewrite the fact that a is less than -7/4 or a is greater than 1. Now, whenever you're graphing an or statement, you put both graphs on the number line. So we'll put 1 here, 2, 3, 0, -1, -2, -3, -4, -5, -6, -7. Okay, graphing a is greater than 1 means I put a circle at 1, don't fill it in, and graph to the right, shade to the right, like that. -7/4 is -1.75, so that's going to live right around here. So put a circle there, and since it's a is going to be less than that, we shade everything to the left. So what this means is I can plug in 2, I can plug in -7, I can plug in any number that this red shading represents, and that would make this statement completely true. Okay, so absolute value inequalities, great or in this case, less than, super exciting. We have ourselves an absolute value inequality. Whenever you have an absolute value inequality, the first thing you need to do is get the absolute value all by itself on the left. Well, it's not. In fact, we have 2 things to do to make that happen. So let's add 10. Let's add 10, and that'll at least get rid of the -10. So 9 times the absolute value of r minus 2 is less than -63. Now, in order to get the absolute value all by itself, divide everything by 9, and now we have, and I'll write it out here, r minus 2 inside the absolute value is less than -7 Don't need to flip any signs for any of that. There you have it. Now that we have the absolute value all by itself, we can split this up into two inequalities. Each inequality is going to have whatever's inside the absolute value on the left, like that. One inequality has you keeping the symbol and keeping the right side. The other inequality has you flipping the symbol and the opposite of the right side. So the opposite of -7 is +7. Now, the other key thing here is we have a word in between. Now, the word is completely dependent on the symbol that you have right before you split these up into two inequalities. This is a less than, which means it's going to be and. I remember a phrase that I use every single time, great or less than, and since this is less than, it's going to be and. So you treat these problems the way you would treat their own individual guys. You add 2, cross you out, r is less than -5. You add 2, cross you out, r is greater than 7, 9. I don't know why that took me so long. Now what you do is this is an and statement. So you make yourself a little rough draft, right? You make yourself a little rough draft and you say, all right, -5 is here, 9 is here, and I need to find out where both of these graphs intersect. So if your r is less than -5, you would be a circle at -5 going to the left. If your r is greater than 9, you would put a circle there and go to the right. Wait a minute. If my answer is supposed to be where these two lines overlap and they don't, that means I have no answer. So the answer for this guy is no solution. There is no number. There is no number that I can plug into here and get a true statement at all. So that's my guy. Simple. Okay, that'll happen from time to time. I did a problem previously that it was infinite solutions. This one is the no solution variety. You didn't do anything wrong. I certainly didn't do anything wrong. So that's what we get here. Isn't that neat? It's neat. All right, we have ourselves an absolute value inequality. Whenever you have an absolute value inequality, step number 1 is to get the inequality all by itself on the left. Do that first, you add 3 to everything. So let's add 3. The 9 is still there. The absolute value of 1 plus 8n is still there, but now we have greater than or equal to 81. What a pleasant number, because the next thing that we have to do is get rid of that 9, and we do so by dividing 9 from both sides. So I'm going to write it over here because now it's important. 1 plus 8n in my absolute value is greater than or equal to 9. Now that we have our absolute value all by itself, we can split this into two separate inequalities. One inequality has my left side the exact same, and the other inequality has my left side the exact same. One inequality has my right side the exact same, and the other inequality has my right side flipping the sign and making it opposite, like so. Okay, so greater than or equal to 9 is now less than or equal to -9. Now, we need a word in between. The word is dependent on the symbol that you have right when you split things up. This is greater than or equal to. If the symbol is greater than or equal to, it becomes an or statement. I remember the phrase great or less than. Well, this is great or, so it's or. See what I did there? Math. So I'm going to solve each guy individually. I'm going to subtract 1. I'm going to subtract 1. Now I have 8n is greater than or equal to 8. Divide by 8. Divide by 8. N is greater than or equal to 1. Lovely. This one, not so much. Subtract 1, subtract 1. 8n is less than or equal to -10. Divide by 8, divide by 8. And n is less than or equal to -10/8, which simplifies to -5/4. 5/4. And the word or is in between. Okay, so that's my guy. So whenever I have an or statement, I graph both lines on the same number line. And this one's going to be pleasant. I care about stuff greater than 1, less than -5/4. So I'll put a 1 here, 2, 3, 4, 0, -1, -2, -3, -4, -5. Like and subscribe, -6. Subliminal message. If I want to graph n is greater than or equal to 1, I fill in the 1 because it's or equal to, and I move to the right. Negative 5 over 4 is negative 1.25. So negative 1.25 lives in between negative 1 and negative 2, but closer to negative 1. I'm going to fill that in because we're allowed to count it, and I'm going to go to the left. So what this dark line that I'm drawing represents is I can plug in any number like negative 6 or negative 3 or 1.5 or pi into the original equation, and it'll become a true statement. Okay? So that's how you solve and graph a nice absolute value inequality. Hope this helps.